All right, today with exponents, we're going to look at properties of radicals. What we want you to be able to do is simplify radical expressions using properties of radicals. Radicals, again, are like any type of roots. So for any real numbers, A and B, this first product property holds, saying that if you have some kind of root, and the number under the root can be split into two numbers that are multiplied by each other, you can split them into two separate roots of the same thing. An example would be if we had square root of 16x to the fourth power. The two things being multiplied in here are 16 and x to the fourth, so we can split that into square root of 16 and square root of x to the fourth. And then using some of the things we learned before with roots, square root of 16 we know is 4, and then square root of x to the fourth would be x squared, and so that would be the answer, simplified answer to the problem. If you are dividing, same thing. So the quotient property says if you're dividing or taking the square root of or any type of root of a fraction, you can split it as that root over the top number, the numerator, over the root of the bottom number, the denominator. So an example here would be if you had square root of 36 over x to the 6th power, we could split that up into square root of 36 over square root of x to the 6th. Again, using what we know about this, square root of 36 is 6. Square root of x to the 6th power would be x to the 3rd. And that would be the simplified answer there. All right, so some things we want to remember when we're simplifying these is that most of the time when simplifying a radical, we're trying to eliminate radicals from a fraction. So we don't want radicals under the bottom or in the denominator. So what we want to do is what's called rationalize the denominator. Okay. Okay, so to eliminate radicals from denominator, we want to rationalize the denominator. All right, so here's an example. Square root of 9/5. Using that property we just talked about, we know this is going to be square root of 9 over square root of 5. Square root of 9 is a perfect square, so we can simplify that. Square root of 5 is not. However, a lot of times, especially on the ACT, the answer might not have that radical listed in the denominator. So if you want to what's called rationalize it, then what we want to do is multiply this by that radical. So we want to multiply by the exact same radical to the bottom. Okay, now whatever we do to the bottom, though, we also need to do to the top to keep it the same amount. Basically, anytime we do this, if we multiply by square root of 5 over square root of 5, that's just the same as 1. You can always multiply something by 1 and it stays the same. So we're just changing the way it looks, not changing the value. All right, so if we multiply this out now, on top we got 3 times square root of 5. On bottom we got square root of 5 times square root of 5. That's square root of 25, which we know is 5. And so rationalizing this problem ends up being 3 square roots of 5 over 5. That's probably how it would look on the ACT test. So this right here is the same as this. They're equal. If you type both into a calculator, you'll get the same approximate decimal number. It's just that this one doesn't have the radical in the denominator. All right, so we're going to work on simplifying a bunch of radicals today, and then just how you should go through and do that. First one here, just a straight up number. We've done these before. You're again looking for those perfect square numbers like 4, 9, 16, 25, 36, 49, 64, and so on. Do any of those numbers divide into 198? If you get a number like 198 and you're not sure, just start dividing it by. If you try dividing it by 4 doesn't really go in there. If you try the next one though, 9 does. 198 divided by 9 gives you 22, and so we can split this into square root of 9 times 22. Okay, 9 times 22 is 198. Now using that property before, we know that's the same as square root of 9 times the square root of 22. Simplifying square root of 9, the perfect square one, we get 3 square roots of 22. That is now a simplified version of what we started with because we pulled out a number out of the square root. All right. We want you also to be able to do ones if there maybe is already a number outside the square root, but there might be some kind of way of still simplifying more. So if we look here, we do have this 3 already out, but 54 still has a perfect square. So we can look at doing that even more. 54 is the same as 9 times 6. So if we think of it as 9 times 6, and now split these up into separate radicals, we can simplify the perfect square one. Square root of 9 becomes 3. Square root of 6 doesn't really simplify into anything nice, so we'll leave it as square root of 6. And now multiplying these two 3's we have together, we get 9 square roots of 6. That's a more simplified version than what we started with because we pulled more stuff out of the radical. We also want you to be able to do this if there's variables. Okay, so in this case we got x to the 7th power underneath the square root. Okay, we again want to split that up. So here, square root, we can take square root and simplify if that power's even. However, here it's an odd number. So what we'll do is we'll just say this is the same as x to the 6th times x to the 1st power. Okay, we still got 7 x's underneath that radical side. Now we'll split it into two separate ones, x to the 6th and just our 1x. Okay, the one on the left here simplifies. Square root of x to the 6th is x to the 3rd power. The one that doesn't simplify is the one left in there, so we'll leave that in the radical sign. And again, we took out what we could out of the radical sign, and we leave in whatever doesn't, we're not able to take out. Okay. Same thing if you got a cubed root or any other type of root to a higher power. You're trying to figure out how many can you take out here and how or what's going to be left inside. Here is, since we got cubed root, we want some power of 3 or factor of 3 as our exponent here. So if we look, we could do x to the 3rd power. We can go even higher though, x to the 6th power. I think we can even go higher. We can say x to the 9th power. That would simplify. And so if we took 9 x's out of the 10, we still got 1 left. So splitting this into separate ones, we'd have the cubed root of x to the 9th and the cubed root of x. The one on the left again simplifies. That would be x to the 3rd power. And then what's left is 1 cubed root of x. So that would be the simplified version. We want you to be able to, if they got numbers and variables too, then we still should be able to do it. 128, our number here is not a perfect square, so we want to see, do any perfect squares divide into that? I think some do. I think if you check 4, 4 divides into that, but I think we can go even bigger. 9 doesn't. 16 also divides into that, but I think even bigger than that, if you keep going, we have 64. 64 goes into 128 2 times. So what we'll do is we'll split this into two radicals here. This is 64 times 2 is the same as 128. Okay, so splitting it up, let's pull all the stuff that we can take the perfect square of. 64 we can. That's going to come out nice. X to the 4th, that one we can simplify, and same with the y one. The one we can't is the 2. Square root of 2 doesn't come out to be a nice number. So now it's taking the square root of everything on the left one. That is 8x squared, y to the 3rd. And then since the square root of 2 doesn't simplify, we'll just leave it as square root of 2. So that would be the simplified answer there. If you have multiple radicals, probably the best thing to do would be to first combine them together and then see what simplifies. So just like we split them apart, we can push these back together into one. So this would be the same as multiplying everything together inside one radical sign. So if you take 24 times 6, you get 144. X to the fifth and x to the first, we add their exponents, so x to the sixth. Y the third and y, add their exponents, you get y the fourth. Now simplifying this, 144 is actually one of our perfect squares, so that's 12. Square root of x to the sixth is x cubed. Square root of x to the fourth would be y squared. Simplified answer. All right, on the back, this next one, now this one doesn't have a lot of simplifying to do. We can't take the square root of 5. 3 is pretty much simplified, but this is one of those, if you don't see that answer on the ACT, then what you want to do is what we talked about before, rationalize the denominator. To do that, you want to multiply by whatever radicals in the denominator. In this case, square root of 5. So we're going to multiply the bottom by square root of 5, which means we got to multiply the top by square root of 5. So if we multiply that, and with fractions, you always multiply across the numerator and denominator. So on top, we got 3 square roots of 5. On bottom, square root of 5 times square root of 5 is square root of 25, which would be 5. There's the simplified answer. Okay, let's try another one. So on this one, we got square root of 6. So that's the one we're going to multiply by square root of 6 over square root of 6. So multiplying that, we get 2 square roots of 6 on top. On the bottom, square root of 6 times square root of 6 is square root of 36, which would be 6. This one we actually can simplify a little bit more here because we got 2 and 6 on top and bottom. So if we simplify that just like you would a fraction, 2 over 6 simplifies to 1 over 3. And so we could simplify this one to square root of 6 over 3. So that would be rationalizing the denominator on that one. All right, if you can also do these with variables. So if you had something like this, take the square root of the top and the square root of the bottom. Square root of the top would be m to the fourth power. If we took the square root of what's on bottom, that would be n to the third power. And that would be this. That would be the simplified answer there. Why don't you pause the video, try 10 on your own, see what you get. All right, let's see. On the top here, if you take square root of 9, you get 3. Square root of x to the fourth would be x squared. Square root of 16, you should have got 4. That would be the simplified answer there. Same thing if you got higher powered roots, like this one is a cubed root. Okay, so cubed root of x to the ninth would be x to the third power. Remember, we kind of want to divide these. You want to divide that one by that one. Cube root of 64. Now this one's tempting to put 8, but don't do it because that's the square root of 64. This one's the cubed root of 64. You got to think what number times itself 3 times would equal 64. So you could try like 2. What's 2 to the third power? 2 times 2 times 2. Well, that's 8. That doesn't work. We could try 3. 3 to the third power would be 3 times 3 times 3. That's 27. That doesn't work. Let's try 4. 4 to the third power, 4 times 4 is 16 times another 4 would equal 64. So the cubed root of 64 is 4. So that would be the answer there. So be careful with 64. If it's a square root, yeah, it's 8. If it's cubed root, it's actually 4. All right, why don't you pause the video, try number 12. Now notice it's a cubed root. All right, let's see what you got. Cubed root of 27 would be 3. Cubed root of y to the 15th, divide 15 divided by 3 is 5. On the bottom, cubed root of x cubed would be just 1x. Cubed root of z to the 18th would be z to the 6th power. Would be the answer there. Next one. Now this one's a fourth root. Okay, so you got 2 radicals. First step on one like this, I would probably combine this into one thing and then try to simplify from there. So you got 5 times 4. We want to multiply the stuff outside the radical sign. That would be 20. And now let's multiply the stuff inside this fourth root. And so if you take 24 times 54, you get 1296. Um, multiply the x's, x to the third times x would be x to the fourth power. Okay, so next, okay, so to do this on the calculator, what you're going to want to do is pull up your math button, and then once you select the math button, this one with the x square root, number 5, that's the one that you're going to want to use. Now, in this particular calculator, one similar to it, you have to first hit the root that you want to do. So here we want to do the fourth root, so type of 4. Then select that x square root one, and then type in the number 1296. Hit enter, and it'll give you the fourth root of this number, which is 6. Okay, so what we have now is the 20 that we had times, this is going to be times 6, and then the fourth root of x to the fourth, we divide 4 by 4, we get x to the first power. And so now multiplying 20 times 6, the answer would be 120x. So all that stuff that we started with simplifies down really nicely to 120x. All right, number 14 is a cubed root one. Why don't you try this last one on your own and see what you get? Okay, doing similar thing, 7 times 3 is going to be 21. Let's multiply these two cubed roots together. So if you take 75 times 45, that comes out to be 3,375. And then 8 to the 4th times a squared, if you add the exponents, you get 8 to the 6th power. Okay, so now doing this cubed root one, you can also do cubed roots again on the calculator. If you hit the math button, you can do the same thing we did with the fourth root. This one actually does have a cubed root button there, number 4. So if you type that in and then type the number, this comes out to be 15. And so that's 21 times 15. Cubed root of 8 is 6. 6 divided by 3 is 2. So now you just got to take 21 times 15, and then it comes out to be 315a squared for the answer. So hopefully you got that when you tried it. All right, try out those practice ones now.